Hi, this is Keith from ProTutor, and we're working on a calculus problem here on limits and using the definition of a limit to show that the limit exists. It's one of, I'm sure, your favorite topics. I know it was one of mine when I was doing first semester calculus. It looks like the definition looks like something like the limit as x goes to a of f of x equals L means that for every epsilon greater than 0, there is a delta greater than 0 such that if x minus a is less than delta, then f of x minus L, the absolute value, is less than epsilon. And really, when it comes to these problems, finding or the proving the limit exists at a point, it really comes down to this this conditional right here. And what I do is I actually break this down a little bit and call this guy the antecedent and the consequent. And the reason I do that is, well, that's the standard language for conditional statements. But when you think of, when you work through a proof of these things, it's typically, it really comes down to you're using the antecedent here to prove the consequent. And when we do that, there's a couple predictable steps that we go through to actually turn that antecedent into the consequent. So why don't we actually do a problem to illustrate this? Let's do the limit as x goes to 2 of f 5x minus 3 equals 7. The first step is to write down what it is that we have to prove. And that is this conditional statement in terms of in the A's, the f of x's, and the L's are all transposed into the proper place within the conditional statement, that such that it specifically applies to this problem. So we need to prove if x minus a is 2 is less than delta, then f of x, which is 5x minus 3, minus L is 7, is less than epsilon. That's what our task is in this problem. Now, what we do is, to do this is we have to come up with a candidate for delta, which will link these two statements together, because right now there's no linkage between the delta and the epsilon, and the name of the game is to be able to find a delta such that this it causes this to be true, and without a linkage to the epsilon, there's no way that we can actually make that true. So we need to find some sort of delta that is a function of epsilon such that we can transform the antecedent into the consequent. So the way we find a candidate delta as a function of epsilon is to do a sidebar calculation on the consequent and just see if we can't transform the form of this into something that more resembles the antecedent. So let's see, So that would be 5x minus 10 is less than epsilon. 5 times x minus 2 is less than epsilon. And then x minus 2 is less than epsilon over 5. And this is a clue here because this absolute of x minus 2 appears over in the antecedent. So the delta candidate that we'll use is going to be delta equals epsilon over 5. Now actually use the delta candidate to transform the antecedent into so we have x minus 2 is less than delta, which is equal to epsilon over 5. So we have x minus 2 is less than epsilon over 5. Our sidebar calculation over here points is usually a clue as to how to transform it. Let's multiply by 5. And that's what we wanted to prove. Thus, the limit exists. With that in mind, now we can actually turn to the problem that was specifically asked about in this question. The limit of 3x minus 5 as x goes to 4. We actually haven't gotten a what the limit exists, what the limit actually is. So if you haven't found yet or haven't learned yet that generally when the limit exists, it's you're able to substitute in the limit value into the f of x. So that would be 3 times 4 is 12 minus 5 is 7. So why don't we go ahead and prove limit as x goes to 4 of 3x minus 5 is equal to 7. So our first step is to write out the conditional if x minus 4 is less than delta, then f of x is 3x minus 5 minus 7 is less than epsilon. That's what we have to prove. And we need to transform our antecedent into our consequent. And we need to do that, we need a link between them. And so we need a sidebar calculation to come up with a candidate. So 3x minus 12 is less than epsilon. 3 times x minus 4 is less than epsilon. And epsilon over 3 looks like the way to go. Use delta equal epsilon over 3 to transform antecedent into finally, let's actually transform it, starting with the antecedent. Start with x minus 4 is less than delta is equal to epsilon over 3. X minus 4 is less than epsilon over 3. And as our sidebar indicates, we'll have a straight shot. Three x minus 12 is less than epsilon, and then that's going to give us the 3x minus 5 minus 7 is less than epsilon. And that's what we wanted to show. We hope that we've answered all your questions, and thanks for watching.